Lesson 1-3, more equivalent fractions. In my opinion, some of the ways that this lesson has been presented in the curriculum make it more confusing than it needs to be. In the end, when I think about equivalent fractions, I simply think of the rule: what you do to the top, you do to the bottom. What you do to one side, you do to the other. And that operation could be multiplication if you're starting with smaller numbers and going to larger numbers, or it could be division if you're starting with larger numbers and going to smaller numbers. Let's see that in action. Number one, here we've got the original fraction that actually practice problems 1 and 2 are going to be referring to as 2/5. Clearly, this model has been divided up into 5 equal parts. 2 of them have been shaded. Therefore, the model at the top represents 2/5. Good. Taking a look at number 1, imagine that we took each of those unit fractions, each of these 1/5, and split them into 2. Now, you could say that each of these represents a 1/10. Two-fifths is therefore equivalent to 4/10, because what we do to the top, we do to the bottom. I take my original numerator of 2, I multiply it by 2 to get 4. I must do the same to the bottom. My original denominator of 5 multiplied by 2 gets me 10. So my multiplier in this case is 2. The word multiplier, as it's being used here, simply refers to what I have multiplied the top and bottom by in the original fraction to get my equivalent fraction. Taking a look at practice problem 2. Again, we're still dealing with 2/5. That's the original value. But now I am taking this model that has been split into fifths, and I want to show it split into 15ths, which means I'm going to take each of my original parts and split them into 3 equal sections. Now, each of these parts represents 1/15 of the whole. My shaded part altogether represents 6/15. Connect this back to the original 2/5. What I do to the top, I must do to the bottom. In this case, to go from 2 to 6, I needed to multiply my numerator by 3. Must do the same to the denominator to show that when I use a multiplier of 3 to my original fraction of 2/5, 2/5 is equivalent to 6/15. The next two practice problems are going to be the same concepts, just done in reverse, where instead of using multiplication to show equivalent fractions that started with smaller numbers and became shown as larger numbers, we're going to, as I said, do the reverse. We're going to start with a fraction that's shown using larger digits and use division to rewrite them as equivalent fractions with smaller digits. Again, very wordy, I know. And as I said at the start, in a way more confusing than I think it needs to be. Just keep coming back to this idea that what you do to the top, you do to the bottom, using multiplication or division, and you'll be good. All right, the original model of this fraction is showing 8/12. Clearly the whole has been divided into 12 equal parts. 8 of them have been shaded. let's say, for the purpose of question 3, we were to take each of these 12ths and group them into 2 parts. Using a divisor of 2, we can show that 8/12 is equivalent or equal to 4/6, because what we do to the top, we do to the bottom. And in this case, we are going to divide the numerator by 2. 8 divided by 2 is 4. We'll divide the denominator by 2. 12 divided by 2 is 6. And show that this way as well. What did we really do? Well, if you think about the original model, we had 8/12, and then if we see this equivalent fraction 4/6, we simply bundled or grouped each of those 12ths into groups of 2. So where you had a 1/12 and a 1/12 before, now you combine them to get 1/6. Let's take a look at this example now, where we're going to try to show how the original fraction of 8/12 could be rewritten as an equivalent fraction where the denominator is 3. Okay. So to do that, we need to take the whole and divide that into 3 equal parts. That'll look something like this. There's one part, there's another part, and there's another part. We can clearly see that the 8/12 represents 2 of the 3, or 2/3. My divisor, well, what did I need to do to the top? To the numerator, if I start with 8, I need to divide by 4 to get 2. If I start with 12, therefore I also need to divide by 4 to get 3. My divisor is 4.